Good afternoon. Today is Tuesday, August 16th, 2015. For all of you snow lovers out there, such as myself, who were so disappointed if you lived in New York City and did not get the snow Boston got, you got the North Atlantic Oscillation to thank for that, for being so positive, or neutral, instead of going negative. This year is a little different. How is it going to be different? We have a major player this year that's coming onto the playing field. We got an El-Nino, a crazy powerful El-Nino. Just look how warm the Pacific Ocean is. And especially, this is unbelievably warm. This is definitely going to be a cold signal for the East Coast. A lot of ridging. If this stays warm, big snowstorms for the East Coast. Major ones. This is a classic example of a positive Pacific decadal oscillation. This is why the 1970s were so brutally cold on the East Coast. This is why we got all these blizzards, the 78 blizzard, the blizzards of the early 80s. I will show you examples of the PDO, the Pacific Decadal Oscillation. So the PDO, flips every 10 years. That's why it's called decadal. Roughly flips every 10 years. That's what happened in the late 70s. It was negative, but this is the warm phase. This is what you want to see if you want to get a big snowstorm. When it's in the warm phase, you get a lot of snowstorms. Especially, there was some big snowstorms, I believe. There was a 1947 storm. It's always when it gets positive. How was it, some of the biggest storms in New York City's histories happened when the PDO goes positive. But the most extreme positivity case was right in the early 1940s. The Atlantic Multi-Decadal Oscillation, the AMO. Let's look at the AMO index. Okay, this is the Atlantic Multi-Decadal Oscillation, the AMO. I got my weather conference is to thank for this, and of course an actual weather service. And I wish I could just 1856 to present. This is showing about how positive it is. Let's look at the year of 2006 and 7. The year we didn't get a lot of snow. It's been mostly, not going, maybe up to 23. Of course, negative 99s mean, of course, it's yet to. They haven't got any data yet. Usually, when the NAL goes negative, especially the year of 2011, 2012, 2013, it almost looks like it's always the same. So I want to check out this area. This is where I'm trying to look for. For a major snowstorm to happen on the East Coast, you need three major factors. You need the North Atlantic Oscillation to be negative, which is usually created by a blocking high over Greenland, which is usually caused by warm waters here. You get a block over Greenland. That's why it's called the Greenland block. It's usually right here, and that's when you get nor'easters coming up the coast, and they slow down or stall. You don't always need a Greenland block for a major nor'easter to stall or slow down and dump a lot of snow. For example, if you have a negative Arctic oscillation, you have a positive PNA, and you get a clipper system, like what happened last year when Boston got 3 feet of snow, Winter Storm Janice. That was an exact example of what I'm talking about. Clipper, Alberta Clipper. It was a pretty strong one, actually. It went down like this. It came right off the coast of North Carolina. And once it hit the anomaly, which was really warm here, it's not so strong now. The anomaly becomes more noticeable in the winter. It's, the Gulf Stream. The Gulf Stream right now is a little cooler than normal. But you can see a little bit of warmth here. Warmth over here, warmth over here. The waters here, a little warmer than normal. The waters right off of Africa are warmer than normal, right around here. So we should have some tropical waves be coming off, but a lot of the Saharan dust layer, you got that, and you got the El-Nino shearing the storms off over the Caribbean. Usually with an El-Nino, most of the tropical systems form right around here, not the Cape Verde systems. The Cape Verde systems are not a threat during such powerful El-Ninos, but you can still get storms. Like Andrew was, I think, during an El-Nino. There was another El-Nino year, 2010, 2011. We had a lot of storms, I believe. We had a couple strong ones around 2008, 2009. And you remember the winter, this fall of 2009 when we had Ike. That was, I think, September 2009. We had Ike. we did have a near El-Nino conditions, and we still had a major storm. You see that cold water, that's definitely Ike there. Let's go about a week later, I think September 17th. It's less noticeable, but look. 2012 was definitely, I think, a weak El Nino year. Because there was a little bit of warmth here. Even though it was cool, you did notice a little warmth here. But it was kind of almost a neutral setup. But what allowed Sandy to be such a monster was, to come into the East Coast was all this warm water here, which led to the Greenland block. Usually when you have warmth here, you have blocking patterns. It's kind of a setup that you usually see. One year that I remember seeing a lot of snow was 1999-2000. We had a couple major storms, especially around the year. It was I think January we had some major storms. January 2000. So this was like December, January. So it was not too bad. The anomaly was very strong. I think that's why we had some big storms. A lot of warm waters just southwest of Australia. Waters around Antarctica are really chilly, but in December 28th, the waters, the ice didn't really go that far north, but the water's still bubble normal. Today, go up to 2014, go up to 2015. You want to go where we are now, and you see full global. You'll notice, the waters around Antarctica are much cooler, very cold. See that little breaking up there? That's where sea ice usually is, and it looks like that a lot of sea ice got broken up here. It's usually broken up sea ice. Go a week before. You'll notice it, or maybe that's broken up sea ice. I don't know. Or it could be a glitch, but you see how it broke up here. That's because a lot of storms came over here, so that's probably broken up sea ice. And that's actually been noticed by. That's actually glaciers, I believe, that broke off. And I'm gonna go to National Snow Ice Data Center, Oregon. I'll show you what I'm talking about. How there's been some rapid changes in Antarctic sea ice. Arctic sea ice, is still well below normal, but we're not declining rapidly like we were in 2012. You see how there's like a little river. It's like an island of water in the middle of ice. It's kind of unusual, but that'll probably become that little sliver of ice will probably weaken, or hopefully will stay together. There's ice here, which is unusual. The Hudson Bay only recently completely became ice-free just a few weeks ago. So there's a lot of below normal water temperature still there. So see, there's still ice here, so it's well below normal here. So in Baffin Bay, it's well below normal. But going to average sea ice, I'm going to go to interactive data. We're still below last year and the year before, but you see the rate of decline is slowing down, but it's still not below last year's and below 2013's levels. So let's say it's a year more like 2008. It's probably going to go down like this and then and shoot up. So it's probably will be end up around somewhere around here. I actually thought we might actually go below 2012 levels when we were around this period. I mean, look how below we were. Like, I actually thought we were just gonna go like this. Thank God I was wrong. Could it be a year like 2009? Probably not. I think it's gonna be a year more like 2008. But I'll show you something that I'm noticing right now. The rate of decline is slowing down a little bit, but we're still going out really fast. And we were, how there were some big storms that broke up Antarctic sea ice. Remember I told you that? And that is characterized by this is what is going on. You see that? We suddenly went up from above normal to suddenly below normal. That is where we lost the sea ice. Right, here. Oops. Yeah, right there. When I showed you all those ocean temperature, the SST anomalies for today, or a couple days ago, that's where we lost sea ice. We lost sea ice here, 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 and here. I mean, look at that. Look at all that, sea ice. Look how far north it's gone. Wow. I mean, I've never seen that before. That's because the how crazy it's been flipping. I'm going to show you the Antarctic Oscillation. The Antarctic Oscillation has been very unstable this year, which is not normal. Like you know, the Antarctic Oscillation. So NAO, NOA. And so I'm going to show you the Antarctic Oscillation right now. I'm going to show where the NAO is right now. It's actually saying it's going very negative, which is unusual. Usually, you know, you want it to be negative in the summer, or a negative means, you know, the high pressure system. If it stays a lot of negative, that means, you know, blocking, which means the water has a chance to warm up. But I'm going to go to the AAO. Very unstable, very unpredictable. Look at that. I mean, just look, oscillating like crazy from positive to negative, positive to negative. I mean, just look at that. That's why it's been like that. Last year it was more zonal, where it's, you know, it slowly shifts over maybe a couple weeks, but it's shifting every week. It's just going up and down, up and down, up and down, up and down, and that's not normal. I'm going to show you that on weather.co.edu, how, you know, the shifts may have been more gradual. I think I've made videos, you know, depicting how, you know, shifts were more gradual, you know, versus very, very extreme shifts. And there's also been a lot of storms that have been, you know, just going around Antarctica. I mean, look at this. I mean, look at that. You see how it's just going, look how far north the crazily Arctic air is going. I mean, last year it did go a little further north, but look at these, you know, how strong these storms are. I'm going to show you in temperature. These are very, very strong storms. I would say, I think that's a maybe 950 or 40 millibar lows. I mean, look at that. 924 millibars. 924. Passing right between the tip of South America and the northern tip of the Antarctic Peninsula. 924 millibars. I don't know if that's the strongest Antarctic storm ever. It's probably not. But 924 millibars. And if that was a tropical storm, do you know how strong that would be? If that was a tropical system, that would have been around a Category 4 hurricane. I mean, some Cat 5s have 924. Sandy was 943 at strongest. Even when it was, you know, Cat 3 in the Caribbean, it didn't get that strong. I'm just telling you, that's insane. There's also abnormally warm water temperatures in the Gulf of Mexico. Look at that. That's upper 80s to around 90. I mean, but look at that, 930. Oh my goodness, that is incredibly strong storm. I mean, I didn't expect it to be that strong. I thought it would be like 950, 940s, but 920? Oh my goodness, 918! 918 millibars! Whoa! That would have been a Category 5, no doubt. I think the strongest hurricane ever recorded, you know, in the Gulf of, you know, Hurricane Wilma was 882 millibars. That's close to being a Cat 5 if that was a tropical storm. Of course, that's why we're having the Antarctica is being chopped up and diced up. Those monster storms coming through. I mean, look at that. Look at the rotation. I mean, just incredible. 918 millibars. I mean, the strongest recorded low for any non-tropical storm, I think it was in the 800s, you know, below 900 millibars. So it's by far not the strongest storm ever recorded, but it's still one of the strongest storms I've ever seen that was non-tropical, and, you know, using these models. You know, the storm in the Bering Sea that was formed because of that super-typhoon last year that caused that big Arctic blast was in the 930s. This is in the 910 millibars. That is very, very, you know, scary. Let me look at the last model run and see what it showed there. I think it showed, let's see, 918, 918, 918, also 918 millibars. It's going to be wrapped up in Arctic air. I mean, this would be a monster blizzard actually now. That would be an Arctic. That would be a 924 millibar blizzard going through. I mean, look at that. That's going to be a monster blizzard over Arctic sea ice. Just monster snow, and because there's all ice here. So this is going to be, that storm is going to be going over ice, and because the temperature differential will decrease, and be less of a contrast, the differential will decrease. The storm, of course, will weaken and peter out, and eventually become 960. But still, this is going to be a big, pretty strong low pressure system. Nevertheless, off the coast of North Antarctica, and see there's some warm air trying to go in here. So, you know, probably there'll be some rain or maybe snow. But Look at that. I mean, that almost looks like a hurricane. 918 millibars. Incredible. I mean, that is what's definitely chopping up this sea ice. That storm is responsible for a lot of the sea ice being destroyed. That storm and this storm, they're both responsible for that. I think I see a 916 right here. Wow. Incredible. 916, 918, 916, 918, 918, 918. But 916 millibars. I don't know what the strongest storm, non-tropical storm is, but I'm going to look it up, actually. Strongest non-tropical storm. Strongest strongest non-tropical low. I think that I'm going to look up. No, Superstorm Sandy was tropical. It had tropical characteristics. Norwegian cyclone model. You know, in general, I think it's good. You know. So I definitely think that is incredible. In the world, like, I'm trying to see the strongest ever recorded. List of the most intense tropical cyclones, but that's tropical. I'm trying to look for non-tropical. I mean, no, of course, that is Labor Day. I think Wilma will definitely, top the list. I think Wilma was 882. Yep, Wilma was 882. Gilbert was 888. Yep, I remember all the pressures, the major ones, of course, because they're the lowest ones. But 918, that was a Category 5. That's going to be the low pressure system of a Cat 5. Katrina, for example, had a low of 902. That's, cutting it close. Isabel had a 915 millibar low, and that became a Category 5. I mean, look at that. That tropical, that Arctic storm, that Antarctic storm is going to have a 915 low, 916 low. So that's going to be as strong as even stronger than some Cat 5s. Cat 5, 918. The Cuba storm, of course. Location. I mean, Camille, the worst of them all, was 900. Allen, which had hit Texas, was 899. Gloria, that hit the East Coast, was 918. It wasn't that strong when it hit, but still. I remember Floyd was a bad storm. But, of course, this is in intensity, not in, wind speed necessarily. I think Typhoon Tip was a very bad storm. I think that was Marge. Of course, these are non-tropical storms, or this is tropical, Marge. Oh, that is a tropical system. Look at that. Cat 5 Marge became Cat 5, so that is a typhoon. I think Tip was the worst of them all. Tip was the strongest, 870. I think that was the strongest system for tropical, non-tropical. 947, of course, this is more like a, Katrina, Sandy was even stronger than that. But, they don't get such strong storms there, so 946 for them is very, very strong. Especially in Pakistan. This is southwestern Indian Ocean. This is more in, near Madagascar, that area. But there were some 800s there. They get Cat 5s there too. That probably did reach Cat 5 strength, but probably not, because the measurement is not as accurate there. Let's see another thing. The cyclone was a low ever recorded, the strongest non-tropical low ever recorded. Oh, in the United States. Let me see. I mean, for a non-tropical storm to reach strongest non-tropical storm ever. Bering Sea, was among the strongest extratropical storms to ever hit that area, probably. I mean, that Antarctic storm, a 16 millibar storm, is incredible. I mean, I cannot believe that is going to happen. It's, 9:24 right now, but still. We're about to get, when a record-setting 924 millibar. Wow. So possibly that could be the strongest storm ever, non-tropical storm ever recorded. Oh my goodness. I think I know what this video is going to be. So this would be dubbed the strongest storm ever recorded, non-tropical. Or the strongest non-tropical storm ever recorded. And this 96L, I'm not picking up it on the models that well, so let's see what they're showing. Oh, there it is. No, it's not really showing much, so... Oh, maybe there is going to be something like way down. It's not even doing much. So all those, the El-Nino and the wind shear. If we do get anything, it'll probably be off the East Coast again. Well, thank you for watching and have a great day. Incredible. Wow. Just wow.